A population is initially 1,000 with a carrying capacity of 10,000. The population after 1 year is 2,500. Write a logistic growth equation and find the population after 4 years. So this is our P naught and this is our K. And so dP dt is going to be R P, and then it will be 10,000 take away P, K being 10,000. Now we can separate that. We'll get the integral of 1 over P 10,000 minus P dP would be equal to the integral of R dt. Now we need to deal with the partial fraction 1 over P 10,000 minus P. So if I've got 1 over P 10,000 minus P, we can write that as A over P plus B over 10,000 minus P. Going clear of fractions, that gives me that 1 is A into 10,000 minus P plus BP. Using P is equal to 0 would give us A is equal to 1 over 10,000. Using P is equal to 10,000 gives us B is equal to 1 over 10,000. And so we get the integral of 10,000 over P plus 10,000 over 10,000 minus P dP equals the integral of R dt, which we can write as RT plus a constant. So we've got 10,000 ln P, take away ln 10,000 minus P. Don't forget to use the reverse chain when you're integrating this, is equal to RT plus a constant. And so we can say ln P over 10,000 minus P is equal to 0.00001 RT plus a constant. We won't bother changing the name of the constant just because we've divided by 10,000. Taking the exponential of both sides gives us P over 10,000 minus P is equal to AE to the 0.00001 RT. And when we took the exponential of this side, of course, we got E to the 0.00001 RT plus C, and then we've just used E to the C, E to the 0.00001 RT, and just called that one A. We've seen this done before in other questions that we've done. We know that P is equal to 1,000 when T equals 0. That was the initial value up here. And so we get 1,000 over 9,000 is equal to A, or if you like, A is equal to 1/9. Okay, so let's just move along. And we'll get P over 10,000 minus P is 1/9 e to the 0.00001 RT. We also know that P is equal to 2,500 when T equals 1. So that gives us 2,500 over 10,000 take away 2,500 is 7,500. That is equal to 1/9 e to the 0.00001 r, which gives us e to the 0.00001 r is equal to 3. Just bring the 9 up over there, and that one simplifies to a third. And so solving it on the calculator gives me r is 109,861. So I have P over 10,000 minus P is equal to 1/9 e to the 1.0986 t. I've dropped a 1 there. It would be 1.09861, but I haven't worried about the 1. And rearranging gives us 9p is equal to 10,000 minus p times e to the 1.0986 t. And so expanding that out gives us 9p is equal to 10,000 e to the 1.0986 t. Take away p e to the 1.0986 t. And then we get 9p plus p e to the 1.0986 t is equal to 10,000 e to the 1.0986 t. And we can factorize on this side, so we get p into 9 plus e to the 1.0986 t is equal to 10,000 e to the 1.0986 t. And so P would be equal to 10,000 e to the 1.0986 t over 9 plus e to the 1.0986 t. And if we multiply top and bottom by e to the negative 1.0986 t, then what we'll get is that P is equal to 10,000 over 1 plus 9e to the negative 1.0986 t, which is where we normally leave these things, in that sort of form. And we just want P of 4. So that is going to be 10,000 over 1 plus 9e to the negative 1.0986 times 4. And that gives us 8999.96, which is approximately 9,000.